count with breaks or without? Everything with breaks or without?
What do you want?
Without. Maybe we should sit there.
Oh, we can do.
Yeah, I can see.
Yeah.
That's not
I'm not sure how to get the pen out, so I have all the writing. Oh. Okay, so we're gonna cover this paper today. And if we have time in the end, we can go back to the multiple choice questions we didn't finish last time. Yeah, so shall we start with question 1? So this is like a written paper. So the other one was multiple choice. I think you have 1 each for the exam. Okay, shall we start with question 1?
Yeah.
So I'll put this in the middle. So whoever is gonna ask a question can write this. So the first question is.
Chemists recognize that atoms are made of 3 types of particle. And the following table of their names and properties. Okay, so it's gonna be first one's proton.
Yeah.
Should I write it? Yeah.
So can you just draw us the structure of a atom, maybe like just a systematic representation of the atom.
Second one, electron.
So what do you have? So for atom, what do you have in the middle?
Plus, right?
Yeah. So I mean, can you draw like a diagram for the atom? So for example, you have nucleus in the middle, and you have electrons around the orbital. So yeah, so if you draw atom like this, so you have nucleus in the middle and the electrons outside. And what do you have inside the nucleus?
Inside, so protons.
Yeah, so it's proton. And what else do you have?
So inside?
Yeah, inside the nucleus. So you have a nucleus which is positively charged. And electrons that orbit around the nucleus. This is like an atom. So what do you have inside the nucleus?
Inside is protons and neutrons.
Yeah, that's right. So which two?
But this is not
neutron.
This is electron.
Yeah, that's right.
Yeah, so third one would be neutron. Yeah. So let's change this will be -1. -1, so it will be 0.
Yeah.
And mass will be n1 and 1, right?
Yeah.
1 and 1. That was
so. So another question: what does the relative mass mean? How do you define the relative mass? So why is it 1? So does it mean 1 kilogram, 1 gram? So what does this unit mean?
Mass.
Yeah, but so mass you can have kilogram, right?
Yeah.
Gram. Those are all the units for mass.
Right here.
So why obviously the mass of a proton is not 1 kilogram, right?
Yes.
Because you have lots of proton.
Yeah.
So what is the mass of this? So
1
unit.
Right?
So what does it mean? Like how do you define this relative mass?
I just remember it.
So is it 1 kilogram, 1 gram? So it can't be 1 kilogram. Right?
No.
So what does this one mean?
1 unit, right?
Yeah. So what does it? So it's 1 unit, but what is this unit?
I don't understand.
So how much does it equal to?
Oh my god, I don't remember that.
So with the relative mass, everything is relative. So they standardized it from the mass of a proton and a neutron.
Yeah. So it's so basically for carbon, what is the atomic number for carbon?
12.
So you have, so it's 12, and you have 6 protons and 6 neutrons in the nucleus, right? So the relative mass is defined relative to this carbon. So a 12th of the mass of the carbon atom or nucleus.
Yeah.
So it's either the atom or nucleus is because, so the difference between atom and nucleus is that the atom has electron, but nucleus don't, because nucleus is part of the atom. But because the electron mass is too small, so it doesn't matter. So either atom or nucleus is fine. So 12th of the carbon mass of carbon atom has a unit of 1. So this is where this one is coming from, and it is equal to 1 time, I think, 1 point. I can't remember what the number is. So it's equal to 1.61 times 10 to the power minus 23 kilogram. I think, yeah. So So the mass of a proton is equal to 1.61 times 10 to minus 23 kilograms. So if you have so this is the mass of a proton. And we can, if we divide everything by this, you get 1. So this is how we define the 12th of mass of the carbon atom. So question B.
Define the term relative atomic mass. So that's the mass of an isotope of an element relative to a scale where 1 carbon-12 isotope equals 12 units, or 1/12 of a carbon.
So that's basically, we'll talk about. So there are 2 terms. One is isotopic mass, one is relative. So isotopic mass is the mass of the isotope. That's simple, right? That's literally what it means. And if you add the term relative, so that's what we talked about. It's relative to the mass of a carbon atom. So a unit of 1 means that it's 1/12 of the mass of the carbon atom. So this 24 means that the mass is 24 divided by 12 times the mass of a carbon atom. So if you have 48, then it's 48 there. So relative means it's relative to the mass of the carbon atom.
So the relative atom mass of magnesium is what's the mean abundance?
Abundance.
Yeah, what's the mean?
So it's basically, for example, you can explain.
Well, okay, so abundance mean, so if you have 100 of them, right, it's like the percentage of
them. And hence the relative isotopic mass of the third isotope of magnesium. Give your answer to 3 significant figures.
significant.
Yeah, I know that.
Okay.
I know that.
Have you done statistics in math?
No.
Okay, so do you know how to calculate an average value of something? Do you know what average value means?
Yes, I know what that means.
Right, so basically the relative atomic mass of magnesium is 24.3. This is the relative mass of the magnesium. But for the magnesium, you have different isotopes, right? You have isotopes 24, 26, and so you have 3 isotopes, right? You have isotope 24, you have isotope 26, and unknown isotope, which the question asks you to calculate. So we define it as X. So we don't know this X, but we want to calculate it. So you have 3 types of isotopes, but each of them have different mass, right? So it depends on the percentage. So for example, if I have 100 of them,
Yeah.
And I have some of this, and some of that, right? But they add up to 100, right? So how much of each? So the average value of the mass of all the isotopes depend on how much of each you have, and also how heavy is each isotope, right?
Yeah, that one I understand.
Yeah. So you need to calculate the average value of the three isotopes. So how do you calculate the average value? Do you know how to calculate the average? So the percentage of the magnesium 24 is given here, which is
okay.
79%.
So
What is the percentage of magnesium 26?
11.
11. So what is the percentage of that?
So it's gonna be
So total is 100%.
15, right? No. Yes,
So-
15.
So you have the total is 100%, right?
Yeah.
So you have 79 of this, 11% of
You're
this.
right, you're not.
So 100 minus 79 minus 11, what is it?
10.
10%.
Came from math.
So you have this much percentage for each. So how do you calculate the average value?
So 24 multiple 70. Right?
Yeah,
24. And 26 with the
What? So 24 times 79%.
It's 9. I thought it's 4.
No.
Okay.
79.
That's
Yeah.
okay.
So what's after this?
That equal 1. No.
So you have first term is
Yeah.
24 times 79%, and
Second one is 26 and 11.
yeah, but what's the relation between first one and second one? So this is equal to like average mass, right?
Yeah.
But
So plus
plus, and the
Yeah.
third term is
we don't know.
yeah, so it's x.
X.
So we have 10
X.
times x is equal to a value which is given in the question.
Yeah. So
24 parts.
and 3.
And then you can solve this equation to get
Yeah.
x. Question C.
I should know this. Okay.
Yeah, so the overall equation. So when you have a salt or magnesium chloride, right? The salt consists of cations and anions, right? So the formula is MgCl2, and you have magnesium and chloride ion. And if you apply a electron current, a thing called electrolysis will happen, and so this salt will become magnesium and chlorine gas. So from here to here, from anion to chlorine gas, positive, a negative, so -1 oxidation state becomes +0. Yeah, so this is what Mark has written here. So this is what happened in the cathode. So cathode is where the electron goes to, and the anode is the electron is where the electron is coming from. So this equation it produces electrons. So this is a cathode, and this equation it gets electron. So this is anode. So and the magnesium. So this one it gains 2 electrons, and it becomes magnesium metal. So they are separate reactions. Question 2.
We might need our data booklet for this one.
I got it.
There's a data booklet.
Yeah, but in Polish. I got it.
Just we need a periodic table.
Yeah, I got it. I think I got it somewhere here. Right here.
If not, I can go and get it.
I can get it. Yeah, I've got it set. Right, go.
I have one here, so it's your.
Thank you so much.
Yeah, so how would you go about doing this question? So have you read?
Okay, so it's magnesium oxide.
Do you want to? So okay, so those are the percentage of the elements
Yeah.
that's given in the question. So we talked about the method of doing this before. So you need to follow certain steps to do this kind of question. So if you are given the percentage of all the elements present in the compound, the first thing you do is you divide. You divide each percentage by the mass number. Okay, so we divide each percentage by the mass number. For example, the magnesium is 31.65%. So you do magnesium is equal to 31.65% divided by what's the mass number for magnesium if you look at your periodic table?
No, 24.
24.3. Yeah. So 24 is fine, I think. So yeah, 31.65 divided by 24. And the right oxygen is equal to
20.84. 16.
Yeah. And then hydrogen
1.31 and 1.
divided by. So it's okay if you just get rid of this percentage,
Yeah.
as long as the relative value between each is fine. Chlorine.
Yeah, 46.20 and 35.5.
Yeah. So and then you calculate each number, and you get. So I'll tell you. So what you get 1.3, 1.3, 1.3, and 1.3. Well, so in this case they are the same, but maybe they are not. You have to see. So the second step is to divide each of the value you got from the first step by the smallest value. So what is the smallest value of? What is the smallest value? It's just 1.3.
Yeah.
Because they are the same. So you can divide them by 1.3 and you get, for example, magnesium is 1, oxygen is 1, H is 1, and Cl is 1. Okay, because you divide each of them by 1.3. And the last step is you write the formula like Mg, and this is the number you have by oxygen 1, H1, and Cl1. Right? So this is the final formula you have. But for example, if you have magnesium 4, if the number here is 4, right, it's magnesium 4, oxygen 2, hydrogen 2, and chlorine 2. So in this case, to work out the empirical formula, which means that you have to divide them by their common factor, which is 2. So you have to simplify it to M2O1. This is the final step. Divide by the common factor. Okay, so in this case, the common factor is 2, so we divide them by 2, so it becomes Mg2O1 H1 Cl1. Okay, so it's just a series of steps you have to follow in order to work out the final formula. Yeah.
Well, okay. So, okay. So, sodium oxide is an ionic compound, thus it's basic. Aluminium oxide is amphoteric because it's not 100% basic or 100%, not 100% ionic or 100% covalent. And then sulfur trioxide is an acid because it has covalent bonding.
Yeah, so it's covalent bonding between those, like ionic between those and this is in between. Okay, so write down the equation of three oxides with hydrochloric acid or sodium. So write down the equation with, so each of this with hydrochloric acid and sodium hydroxide. So what is the reaction of sodium oxide with hydrochloric acid and with sodium hydroxide?
So Na2O. So, yeah.
Plus hydrochloric acid. So that's it.
So it's gonna be NaCl, but Na2Cl. No. Yes.
Yeah, and plus
Plus H2O.
H2, yeah.
Okay.
Yeah, so this
So-
and how, yeah, that's right. Then you balance the equation.
Yeah.
So
So we should put here too and here too.
good.
Yeah.
So what about this with that?
Which with which?
So sodium oxide with that.
NaO.
So it actually doesn't react because this one is basic and base react with acid.
Yeah.
But this one is base, so they don't react. Next one. So does it react with hydrochloric?
So
Because this is amphoteric, so it reacts with both of them.
okay, so it's gonna be La2Cl3, right?
La2. So La2. Okay, so what is the oxidation number of aluminium? Normally, what is oxidation? Well, what is the oxidation number of chlorine?
2.
So it is always -1.
Yeah.
So
-1.
so 3 will be -3.
Yeah.
And then because
Plus
the
2.
total
Yeah, I know.
the total is 0.
So it's 2.
So it's +3, but +3 divided by 2 is 1.5, so it doesn't work. Okay. So what is oxidation number of aluminium? So normally the oxidation number of aluminium is +3. So in this case, it's just AlCl3 plus.
Plus H2O.
Yeah. And then you balance. You can balance later on, but so how does it react with sodium hydroxide?
So it's gonna be Al, right?
Yeah.
Is it OH? Yeah. So La OH OH 3, right?
This.
Yeah.
So it doesn't. So I think just a thing that you have to remember. So basically, so Al, so that react with this, and you get AlO2 minus plus what?
H2O.
Plus sodium. Sodium cation. That's just what you get from the.
Okay. Yeah.
Right. Yeah, so you would have two here. And yeah, you have 2 here. And then it's balanced. So this reaction happens. And finally, what about sulfur dioxide? So, sorry, sulfur trioxide. So, does it react with hydrochloric acid? So we down the sodium oxide, aluminum oxide, and now what's left is sulfur trioxide, right?
Yeah.
So how does it react with hydrochloric acid? It doesn't react because this is acid.
Yeah.
So hydrochloric acid is acid. So it reacts with sodium hydroxide. So how does it react with sodium hydroxide? Sodium hydroxide. How does it react?
Na2SO3.
Yeah, so we have Na2.
Na2.
So it's not SO3 anymore, so it's
It's
SO4.
4.
So it takes a oxygen from
Yeah.
here. And then you have a
Plus H2.
Yeah, plus H2. So you have 2 here, right?
Yeah.
So that's what you get from the reaction.
It might be.
Shall we do the next post turn?
Yep.
Yeah.
So do you know what the contact process is? Contact process. Have you learned about contact? So it's a sequence of reactions in the industry which you can make the sulfuric acid. Yeah, so this is the first step of the reaction.
Wonder how. Okay, wait. I think that's it.
Yeah, maybe you want to explain to.
Yeah. So what do you want me to explain what the contact process is, or?
No, just that reaction. I mean, maybe together with the second one,
Okay.
the second question. So.
So O oxygen is 0, and it's -2, and it's -2.
Yeah. What about sulfur?
Yeah. I know that sulfur here is +4.
Yeah.
Sulfur there. Right.
Yeah, because oxygen is -2 and you have 2 oxygen, so sulfur is +4. So what is the oxidation state of the palladium?
I think it's
So normally it's +2.
okay.
Oxidation +2?
Yeah.
Where's PB exactly? On
So
the periodic
is
table?
is
Is
in
it a
the is one of the
transition?
transition metals. Yeah.
Okay.
I
I would guess maybe plus.
Yeah, you wouldn't know that. You wouldn't know the +2 for the PB, but for sulfur you could. Yeah, you could guess the sulfur because sulfur has 6 outer electrons.
Yeah.
So to reach stable configuration, so it can get 2 electrons to get it. So you can guess the oxidation state of sulfur. You probably wouldn't know the oxidation state of PB. So because you deduce that the sulfur is
I know
-2.
that, yes.
Yeah. So the palladium is +2.
Okay. So
So what has
oxidation of
state?
sulfur goes from -2 to +4.
Yeah.
So +6.
Mhm.
And then for oxygen,
yeah,
it goes
so-
from 0 to -2, so -2 really.
So it might be better if you write like in an extra exam. So like +2 to change from +2 to minus.
Oh no,
minus,
yeah, I would. Yeah.
Yeah, so
Just right.
yeah, so it's oxidation for the sulfur and reduction for the oxygen.
Yeah.
So question B. So because you don't know the contact process, so I tell you the temperature for this reaction is around 400. Is around 500 degree. Yeah. So this question asks us, why do we need? So this is obviously a high temperature, 500 degree. It's quite warm.
Yeah.
Quite hot. So why do we need such a high temperature? So why would this temperature help us in terms of the reaction, making the products? How does this temperature help the reaction going? Yeah, so there are two things to think of, right? So one is the kinetic, one is the thermodynamic.
Yeah.
So the kinetic involves the rate, right? The rate of the reaction, so how fast the reaction is going. So does this reaction happen in like 1 year or a month? You know, 1 hour or like a second? And the second is the thermodynamics, so the equilibrium between those two, because as you can see, the reaction is in equilibrium, right? So the reaction goes both ways, right? So this way and as well as that way. So there's equilibrium. So when it reaches this equilibrium, how do I get this? Because I want this, right? This is my product. How do I get more of this and less of that?
Yeah.
So first thing is kinetics. So how does this temperature change the kinetics of the reaction?
Should I write that?
Yeah, just not the whole sentence, just like some keywords maybe, or you can just tell us what you think.
So high temperature gives us more products than.
Yeah, so for high temperature, first it increases the reaction rate, right?
Yeah.
Because higher temperature, more the molecules will have higher energy. That means
Gives us more energy.
yeah, that means the reaction rate will be faster. You don't have to write.
Yeah.
And the second is thermodynamics. So this you have a higher rate. So the second is thermodynamics. So how does the high temperature change the equilibrium of this reaction? So what do you think? So what does it do to the equilibrium of this reaction? The high temperature. So first, is this a endothermic reaction or exothermic reaction? What kind of reaction is it? Is it endothermic or exothermic? So if you look at this, it's a minus. There's a minus sign in front, right?
Yes.
What does this mean? What does this minus sign mean? Minus.
Yeah.
What does it mean?
Good.
So it means that the energy, like minus means it's negative. Right? So the energy change is negative, which means the energy goes from a high point to a low point. Right? Yes. That's what minus sign means. It's negative. So it means the energy changes from high to low. So if the energy changes from high to low, is it endothermic or exothermic?
Exothermic.
So exothermic, what does exothermic mean? Yeah. Yeah, so yeah, you are right. Yeah, so what does exothermic mean? It means giving out energy, right? So because it changes from high to low, so it gives out energy. So it's exothermic. So this reaction is exothermic, right? So and what does high temperature do to a exothermic reaction? How would it change the equilibrium? So what kind of reaction does a high temperature favor? Does it favor endothermic reaction or exothermic reaction if I have high temperature? So it favors either, so one of them, right? It can't favor both. So which one, endothermic or exothermic? Which one does a high temperature favor? You can say if you know.
High temperature favors the endothermic reaction.
Yeah, why is it?
So to oppose the change that has occurred to the equilibria, which is that the temperature of the surroundings has increased. So it favors the endothermic reaction because it absorbs energy from the surroundings.
Yeah, so it's, or you can think it as like a simpler way. So the higher the temperature, so endothermic is taking energy. So if I have a high temperature, then I'm taking more energy. So the high temperature will favor the endothermic reaction, but this way is exothermic, right? So which way does a high temperature favor, this way or that way? So this way is endothermic, right? Because that way is exothermic. So this arrow is going from that there, and this arrow is going to there. So this is exothermic as you said, and that way is endothermic as because it's right is opposite direction. And as Mark said, the high temperature favors endothermic. Right? So which way does the high temperature favor? Which one? So the product or the reactant? Sorry, the product or the reactant? Which one? Right, okay, so in this reaction, as you said, this way to the product is exothermic. Which means this way is endothermic, right?
Yeah.
And as Mark said, high temperature favors endothermic. So which way does the high temperature favor in this reaction?
That side.
Yeah, because this side is endothermic.
Yeah.
So it favors the reactant. Yeah. So there is like, sorry. So there is like opposing. So the high temperature favors the rate of the reaction, but it also disfavors the products. So there is a balance between the two. But but you need this high temperature because otherwise you wouldn't have the reaction going because the rate would be too slow. Although this reaction favors the reactant, but you need it because you want the rate of reaction to be high enough. Question 2. So
what does it mean?
So question 2, you mean what does it ask you?
No, is it my turn to?
Yeah, you
Okay.
can do it.
Statement explain the pressure conditions that would give the best rate and best yield. Why these aren't actually used. Okay. So the pressure conditions, high pressure would give you the best yield of sulfur trioxide.
Yeah.
Because with the high pressure, the position of equilibrium would move to the right would move to the right.
Yeah, because you have less gas molecules on. So on the left you have 3 gas molecules. On the left you have 2. So this will have a lower pressure because it has only 2. So a high temperature will favor the right hand side because this will lower down the pressure.
Okay. And thus, so the condition is not actually used because.
Okay, so this is one point. So is there another point?
Oh, okay. So
So this is the thermodynamics, right?
Yeah.
We talk about the equilibrium. And what about the kinetics? So there are always two things you have to consider. One is the thermodynamics, one is the kinetics. So what about the kinetics? How does it affect the rate of reaction? How would high temperature affect the rate of reaction?
It would increase the rate of reaction.
It's basically that you have a higher pressure and like the particles are more energetic.
Okay.
So why is it not used?
So it's not used because the position of equilibrium is already far to the right, so there's already a high yield of sulfur trioxide. So it would be expensive to increase the pressure because you need the materials needed.
So it's expensive. So because like a high pressure would require more resources, right? More resources and use more energies. So we want to save some energy and resources, so we don't want this high pressure. Question C.
I don't know.
Right, so basically this question asks you that after you have the sulfur trioxide, and if you put it inside the water, it produces the sulfuric acid.
Yeah.
But we are not doing it this way. We are doing it some other way. So why we don't do it this way? So because so this is a reaction, right?
Yeah.
It happens very fast. And it's the exothermic reaction. So what does the exothermic reaction do? In terms of energy, what does the exothermic mean? So it gives off energy, right?
Yes.
So this is a very exothermic reaction, so it gives a lot of energy. So it's not very safe, right? Because you would have like explosions, very high energetic reaction. So in the industrial process, it's not the safest method. So what is the alternative for making the sulfuric acid? So the alternative is to mix the sulfur trioxide with sulfuric acid first. Get that. Okay, so this is a less energetic reaction comparing to that. And then you can then mix this one with water to get your sulfuric acid. So this will reduce the amount of energy release. Or it won't reduce the amount of energy release, but it will reduce it will be less energetic. So you split them in two steps, and you don't have all the energy going at once. So question D.
Explain why sulfur dioxide is used as an additive in some food and wines. I don't know. Because I know that sulfur dioxide dissolves in water to form H2SO3.
Yeah.
Sulfur Yeah. But I don't know whether.
So what does the word additive mean? What does additive mean?
I don't know.
So it means some like additional chemicals that you put in the food.
Okay.
So why do you want those? So the purpose is to preserve the food.
Okay.
So the additive is to preserve the food. And why do you use sulfur dioxide as additive? So what do you want this preservative to do?
We want it to
prevent the food become bad, right?
Yeah, so prevent it from rotting. Or,
Yeah. So what caused it?
Microorganisms.
Yeah, that's
So
right. It's
bacteria.
like virus, no virus, sorry. Like yeah,
Bacteria.
germs and stuff.
Yeah.
So this one, so the sulfur dioxide will it's kind of like it destroys those microbial organisms.
Okay.
That's all. So it's yeah. Question E. So this is a titration question, right? So do you have done titration before? Maybe Mark, you can tell us.
Okay. So let me read the question quickly. So for 10 seconds. Okay. So you know both the concentration and the volume of iodine. Thus you can find out the number of moles of iodine. So by calculating 12.35 divided by 1000, because it's in centimeters cubed. And
Yeah, so we need to convert the units first. We need to convert that to the decimeter cubed. Yeah.
And then times that by 0.01. And you get the number of moles of iodine, which is by stoichiometry of the reaction the same moles of sulfur dioxide.
So this is a reaction given the question, so we don't have to know like previously before the exam. So basically it says this amount of the iodide react with some amount of the sulfur dioxide. So it asks us to calculate how much is sulfur dioxide. So we know, because we know the stoichiometry, that 1 mole of iodine react with 1 mole of sulfur dioxide, right? Yeah. So if we calculate the number of moles of iodine, we get the number of moles of sulfur dioxide. So how do we calculate the amount of iodine? It's basically given in the question here. We know the concentration, we know the volume, so we can work out the amount. So it's just 12.535 times the concentration. And you need to divide by 1000 because they are in different units, right? As you can see here. And this is the moles of the iodine, which is equal to the moles of the sulfur dioxide.
I think I can do this one.
Okay.
Because I was doing it, but I'm not sure. Actually.
Yeah, you can do it.
Yeah. That's in Polish, but I don't know. Okay, so. So, the second one. So, okay, so how many moles of? Okay, so I need to know N. We have the equals one. Yeah. And we need to find, okay, so that's O2 equals, this is 2 plus 16 plus 16 is 20, it's 32. Yes? Am I right?
Sorry?
It's 64.